Right, my name is Sean Olivier and this is my Chapter 7 quiz problem tutorial. Question I chose is baseball pitching machines are used to fire baseballs towards a batter for hitting practice. In one kind of machine, the ball is fed between two wheels that are rapidly rotating in opposite directions. As the ball is pulled in between the wheels, it rapidly accelerates up to the speed of the wheel's rims, at which point it is ejected. For a machine with a 35 centimeter diameter wheel, what rotational frequency in RPM do the wheels need to pitch a 90-mile-an-hour fastball? Right, so we'll find our knowns and unknowns. Our knowns are the diameter of the wheels, which is 35 centimeters, and the velocity of the pitch, 90 miles an hour. And our unknown is the RPMs of the wheel, which we'll find at the end. Next, we'll convert centimeters to meters. So we'll take the diameter of the wheel, 35 centimeters, and convert it to meters, which is 0.35 meters. Then we'll find the radius of the wheel, which is, we'll use this formula right here, radius equals diameter over 2. So we'll plug in our diameter, 0.35 meters over 2, and we find 0.175 meters. That's our radius. Okay, next we will convert miles per hour to meters per second. And to do that, 1 mile per hour equals 0.44704 meters per second. So we'll use that conversion later right here. For the velocity of the pitch, which is 90 miles an hour, we'll convert it, and those 2 miles per hour will cancel out. And we're left with 90 times 0.44704, and we'll get basically 40 meters per second. Now we'll find the linear velocity of the rotating wheels. We'll use this formula, velocity equals angular velocity times radius. And our knowns, we know that the velocity, which we just found, is 40 meters per second, as well as our radius, which we just found is 0.175 meters. And we'll plug those in. We'll plug 40 meters per second for V, and we'll plug our radius, 0.175 meters for the radius, and we'll solve for angular velocity, and we get 0.57 radians per second. And now we'll just convert radians to RPM, and to do that we'll use this formula, force equals angular velocity times 60 seconds over 2 pi. And our knowns is the angular velocity, which we just found is 228.57 radians per second. And so we'll just plug that into the angular velocity symbol. And when we plug that into our calculator, we find a 2182.7 RPM.